In the last video, you guys understood what is an extrinsic semiconductor, correct? Now there are two types in extrinsic semiconductors, N-type, P-type. Let's talk about what is an N-type extrinsic semiconductor, or in short we just say N-type semiconductor. See, in N-type what we have is we add an impurity which is a pentavalent impurity. See, we all know that there are two elements what we generally use for a semiconductor, correct? Silicon or germanium. Both of them are tetravalent, 4 valency. Now I add an impurity which is pentavalent, 5 valency. Now what we have, see, the 4 electrons of the impurity that is going to share with the silicon atom. But there you have one extra element. But you have one extra electron. That electron what we have, that is going to help in the electrical conductivity. So what we do, we add pentavalent like phosphorus, arsenic. These are the most generally used. Okay, so etc. There are many pentavalent. Not just element, we can also add compounds also. With valency of 5. There are many things like this. Now what exactly, see, how do we represent it pictorially? See, this is the pictorial representation. Now what you are seeing, 4 atoms are bonded, there is a covalent bond, there is sharing of electrons, but that one electron is left out, correct? What you see is what we call as a donor atom. That means all pentavalent atoms or pentavalent impurities, we call that as donor atom. Once you have donor atom, that means when you have a pentavalent, this type of semiconductor is called N-type semiconductor. That means here, electrons are the majority charge carriers, holes are the minority charge carriers. See, just because you have more number of electrons doesn't mean there are no holes, because there are lots of other factors which will cause the movement of electrons and holes. Okay, one could be thermal agitation, or second one could be the kinetic energy itself. Third one electron can come and collide with another electron and both of them can scatter. There is a vacancy. So there are so many cases how these vacancies can be created, as in holes can be created. So you do have holes, but majority is going to be electron, minority is going to be hole. This is what we call as an N-type semiconductor. Okay, just to recap, in an N-type semiconductor, you have extra electron. That's why we call it as a donor atom. It donates the electrons. Okay, so electrons are majority charge, holes are minority charge carriers. Okay, the second type of an extrinsic semiconductor is P-type. So in P-type what we do, we take the semiconductor and we add a trivalent impurity, valency of 3. Like it could be boron, aluminium, or even indium. There are so many. Again, different compounds can also be added depending on what our use is. So when you have 3 valency, what's going to happen? So there are 4, correct? For silicon it is 4, but this impurity has only 3. 3 of them are going to share. One of them is left empty. Like see in the figure what you are seeing, one of them is empty. That means there is already vacancy, correct? What's going to happen here? This type of impurity, we call it as an acceptor impurity or acceptor atom. Okay. Now, in an acceptor atom, that impurity whenever you add, we have P-type semiconductor. Okay. So, in P-type semiconductor, holes are the majority charge carriers, electrons are the minority charge carriers. Just like the P-type just like the N-type, P-type also has similar properties. But here, majority carriers are going to change. Okay. So, in P-type semiconductor, more the number of holes are there, less than the number of electrons are there. Clear? These are the two types of extrinsic semiconductors what we have, N-type and P-type. There are certain similarities and there are certain differences between N-type and P-type. We'll look into those differences and similarities, basically distinctions, whatever we have in the next video.